Okay, so starting off, related rates is understanding expressions within the question. So in different calculuses, related rates problems also involve finding a rate at which a quantity changes by relating that quantity to other quantities whose rate of change are known. The rate of change is usually with respect to time. So one of the first strategies for solving a related rates problem is understanding the problem. So in particular, identifying the variable whose rate of change we need to seek, and the variable or variables whose rate of change we know. So understanding and analyzing the problem for expressions and how they act within the problem help us to solve it. So let's say we have this problem right here that says the radius RT of the base of a cylinder is decreasing at a rate of 9 millimeters per hour, and the height h of t of the cylinder is increasing at a rate of 2 millimeters per hour. At a certain instant, t0, the base radius is 8 millimeters and the height is 3 millimeters. What is the rate of change of the surface area, S of t, of the cylinder at that instant? Match each expression with its given value. So we have a table here that we need to match the expression on the left to the value up top. So we are given 4 values in the problem, and we need to figure out how to describe each one symbolically. So first of all, we want to establish what's given, right? So from here, we see the radius of RT at the base of a cylinder is decreasing. Decreasing is important at a rate of 9 millimeters per hour, and the height h of t of the cylinder is increasing at a rate of 2 millimeters per hour. So right away, from that first sentence, we can gain that R of t is equal to dr over dt, which is also equal to negative 9 millimeters because it's decreasing. And then from that second sentence where it says the height of h of t of the cylinder is increasing at a rate of 2 millimeters per hour. Right, we get h prime of t is equal to dh over dt is equal to 2 millimeters. Right, now, moving on, this is at a certain instant, t0, the base radius is 8 millimeters, right? So that gives us R in parentheses t0 equals 8 millimeters. And then again, the height is 3 millimeters. So that means that h t0 is equal to 3 millimeters. Now, so the values of all other variables, including s in parentheses t0, are unknowns because they didn't give that to us. So that goes hand in hand with identifying the expressions within the equation, right? So, and since r prime of t is equal to negative 9 for any t value, that means r prime of t0 is equal to negative 9. Right, so from this information, what we gathered from the problem, what we were given, we can now fill in the bubbles on the left. So because, as we identified earlier, all other variables, all values of all other variables are unknowns, so that means they aren't given. So S T0, and then as we saw here, R prime team of 0 is equal to -9, so we can fill this one in. And then we have H prime of t. All right, now H prime of t we found equaled 2 millimeters. That would be that. It's understanding the expressions of related rates in a problem.